our project was to create an electric-powered hydrofoil. What a hydrofoil does is it works essentially as an airplane wing, except underwater. So as it moves, there's a lift force which causes upward motion. So in this case, we have a hydrofoil on the bottom of a surfboard which can lift a rider off of the surface of the water.
So here we have a hydrofoil. This thing is connected to the surfboard about 3 feet under the water. As it speeds up, lift is generated and everything rises above the water.
So one of the biggest problems and aspects of our project was waterproofing. It was very important for us to appropriately waterproof each part because the material that we used to 3D print our parts was highly porous, so it allowed water to easily seep through. So, as a consequence, we basically applied liquid rubber to each of the parts. We also utilized O-rings, we used cable glands. Alright, something I personally learned from this project is that sometimes the AutoCAD model does not necessarily translate to a fully functioning real-life model. Like, I got a better idea of what tolerances are and what they actually mean in real life.
Obviously, a huge part of this project was the safety of the user. We wanted to make sure that all the necessary precautions were in place before the user could even touch this thing. So the first thing is we have a dead man switch right here, which is normally attached to the user's ankle. If I were to try and turn this thing on without it, just nothing happens. But as soon as I put this in place, it'll start up. Now the next thing is a controller. I mean, you don't want this thing flying off if you don't have the controller in your hand. So you also have to make sure that you're holding the controller firmly before it will do anything. Now notice it still isn't working because the throttle isn't in the 0 position. As soon as I move the throttle back, it gives me this tone to let me know that it's starting up, and pretty soon here, we'll have a functioning motor. So now, throttle forward. If I were to drop the controller, it stops. Pick the controller back up, still won't go unless I put the throttle in the 0 position. Now we're moving again, and now this time I were to fall off, and the dead man switch came with me, everything gets shut down.
So after presenting, we went to Dorchester Park to test our project since it was pretty nice out. Once we got to the park, we assembled it and we told the rider how to operate it. It took a lot of people to get it into the water, but once it got into the water, it actually floated. And it was much more difficult to ride than we expected, but the rider was still able to get it to go, and we think that is a success in our book.
I feel like that was cool.
Oh yeah, I feel it.
Go, lean forward! Lean forward!
We were able to get it to move in small segments with and without him on it. We weren't able to verify a lot of our requirements that happen in open water, but it still was able to move and function, so we think this is good progress for our prototype. We would like to thank our supporters again, Charge CCV for helping us out with the battery, and Slingshot Sports for helping us out with the surfboard.
These 3 people, why do you...
Sorry.
God damn it!
What's a hydrofoil surfboard?
It's a surfboard that uses a hydrofoil. Well, I got this from Red Mango on my way to this meeting. On my way to this meeting.
Hi. Hello. Hello.
Are there any further interrogations?
I'm trying to have you talking about the box.
Thank God.